I will do problem 24, page 634. This problem says determine the work done on a fluid that expands from I to F as indicated in figure 20.24. What if or how much work is performed on the fluid if it is compressed from F to I along the same path? So he's asking me to find the work done on the gas. أنا علمتكم جيبوا الwork done by the gas, which is the work equals integral PDV. So ليش بيسأل هون هيك بالكتاب؟ لأنه هو شرح بطريقة الwork done on the gas. بس بيرجع بchapter 22 he will explain in a different way. بيرجع بيشرح الwork done by the gas. So I've explained both chapters 20 and 22 in the same way, and we're gonna solve in the same way. ونحن بنسأل بالامتحان مثل ما أنا عم حل. Okay, so we're going to we never ask about the work done on the gas in an exam. We usually ask for the work done by the gas. So we're going to calculate the work done by the gas. So the work done by the gas W, or the fluid, he's saying it's a fluid. Let me write fluid. It's equal to integral from initial to final PDV. Okay, remember that in this case I don't have the types of processes. Anyway, the first part here is an isobaric process at constant temperature, and the last here is an isobaric process, but this one I don't know what is it, so it has no name. This one, it's not an isochoric, neither adiabatic. The adiabatic, it looks like 1 over x. Isothermal, it looks like 1 over x. I have the adiabatic, which is similar to the isothermal in shape. So you can see that this one has no name. So I don't have equations for the middle part of the graph. So simply I will calculate the work using the method of area. Integral PDV is simply the area under the curve. So I will separate my area to 3 parts. Let's say this one, because I can't calculate all the area all together, I have to divide it into parts, and this one, and if you want all the area, okay, it's all there. You can divide the area and say in the way you like it. Okay, I've divided it this way كرمال اقدر احسبها, so you can divide it in the way you like. Anyway, it will be equal to, it's equal to the area under the curve, not minus the area, it's plus the area. Remember that لما يكون السهم going from small to large values of v, يعني رايحة من الشمال على اليمين، لما يكون السهم من عفوا من الشمال على اليمين. Okay, in the same way as I have here, I have the arrow this way. So in this way I have an expansion. The work is equal to area. The fluid is doing work. هو عم يصير في عندي expansion. تخيلوا انتوا البستون في بقلبها غاز، والغاز عم يفتح البستون، يعني عم يكبر الفوليوم. So gas is doing work. So هي بساوي الاريا مش minus الاريا. So it's equal to the area under the curve under the curve, which is equal to, so let's do. Now the first one in blue, it's a rectangle. You can see that the area of a rectangle is base times height, or length times width. So it's 6 times 10 to the power 6 times the width here, it's 1, as you can see. So the distance from 1 to 2 is 1, so times 1. First you have to check the units for sure. So you have here meter cube, this is in SI unit, and this is in Pascal, so it's in SI unit. No need to change units, everything is okay. So I have only to write the numbers. Then let's do the triangle. The area of a triangle is base times height over 2. So you can see that it's from here till here, which is equal to 4 times 10 to the power 6. This is the height. The base, it's equal to 1. It's equal to 1, okay, divided by 2, okay, which is over 2. And then I have this green rectangle, which is, it has a height of 2 times 10 to the power 6, and the base, its base is equal to 2. It's equal to 2. Okay, so I've got everything, and I will get my answer. 12 times 10 to the power 6 joule. So this is the work done by the fluid. If I'm searching for the work done on the fluid, the work done on the fluid, I've called it in the course W external. This is the work done on the fluid, done by the external, by something external on the fluid. It's equal to minus W. It's simply minus 12 times 10 to the power 6 joule. So this is the work done on the fluid. In part B, it says how much work is performed on the fluid if it is compressed from F to I. So if we're going to invert the arrow, not go from I to F, but rather go from F to I, so the integral will be, W will be integral instead of integral from I to F, the integral will be from F to I. You all know that when we interchange the boundaries of an integral, we are only multiplying it by a minus sign. So simply, part B, the work from F to I, it's equal to minus the work from I to F. And the work external, if you're asking for the external work from F to I, it's equal to minus the work external from I to F. Okay? So if I'm searching for the work, إذا أنا عم بمشي من الأف لعند الI, work done by the gas will be minus 12 times 10 to the power 6. If I'm searching for the work done on the fluid from F to I, it will be 12 times 10 to the power 6. They will be just multiplied by minus signs if I'm going in the opposite direction, because simply the integral will be inverted. You all know that. Let me now move to the other problem, which is problem 28. This problem says a gas is compressed at a constant pressure of 0.8 atmosphere from 9 liters to 2 liters. So let's start. We have a constant pressure. So we have a constant pressure. We have an isobaric process. So this is an isobaric process. The pressure is constant. It's equal to 0.8 atmosphere. We started initially, the initial, it's from 9 liters. We ended up with a final volume, which is 2 liters. In this process, 400 joule of energy leaves the gas by heat. So we have lost 400 joules of energy by heat. When he says the word heat, he means Q. So Q here, it is negative. It's equal to minus 400 joule because the system has lost this amount of heat. What's important in this problem is that atmosphere and liter, they are not the SI units for pressure and for volume respectively. Atmosphere is not the SI unit. The SI unit is Pascal. So how to change from atmosphere to Pascal? I will write it here. I've explained it when in fluids. So from atmosphere to Pascal, I multiply by 1.013 times 10 to the power 5, which is usually given in the exam, and it's given like 10 to the power 5 as an approximation. If I'm going to change from liter to meter cube, because liter is not the SI unit of volume, I have to multiply by 10 to the power minus 3. So this is the way we change to SI units. Now in part A, he says, what is the work done on the gas? He's asking for the work done on the gas. نحن عندنا work done by the gas. I will repeat again. You have to know how to calculate the work done by the gas. So that's why I'm only calculating the work done by the gas, and then I'm deducing the work done on the gas. So the work done by the gas, the work done by the gas, W, it's equal to, I have an isobaric process, so it's P delta V. I have everything, so it's P V final minus V initial. It's equal to P, it's 0.8. I have to change to SI unit, 1.013 times 10 to the power 5. V final is 2 minus V initial, it's 9 times 10 to the power, don't forget that to change, minus 3. So I will get minus 567 joule. And this is the work done by the gas. Now if he's asking for the work done on the gas, the work done on the gas, W external is equal to 567 joule. In part B, he says, what is the change in the internal energy? So I have to find delta U. Okay. Part B. So from the first law of thermodynamics, delta U, it's equal to Q minus W. So Q was given to be minus 400. W is already calculated, so it's the work done by the gas. It was found minus 567, okay, which will be equal to 167 joule. And this is the change in internal energy. Let's now do one more problem, which is problem 30, page 635. In this problem, it says a gas is taken through the cyclic process described in figure P20.30. Find the net energy transferred to the system by heat. So he's saying net energy, so energy by heat. It means we have to find Q during one complete cycle. So he's asking about Q of the cycle. Okay, there are two ways to calculate Q of a cycle. This is part A. Q of a cycle is simply QAB plus QBC plus QCA. But again, I have no information about the part which is AB. This straight one. I did not study such straight one, so it's hard to calculate QAB for this process. Okay, maybe for BC it's an isochoric process. It's feasible for CAI. It can be done if I have some more information. Okay, but for AB it's impossible, and I have not much information about that. So I try to calculate it some way else. I will try to use the first law of thermodynamics for a cycle. So delta U for a cycle, it's equal to Q for a cycle. So or I can use this cycle minus the work done by the gas through a cycle. اوكي الدلتا يو للسايكل is 0 لانه انا اذا بلشت من ال A ورجعت لعند ال A, so there's no change in internal energy. I'm going back to the same parameters, so delta U will be equals to 0, but delta U of a cycle is equal to 0 implies this will give me Q للسايكل it's equal to work done by the cycle. طيب الwork للسايكل أنا حكيت قبل إذا أنا عندي I have a cycle and I'm going to calculate the work of a cycle, I can either do the formulas if I know the processes, and if I don't know the processes I can use the area. Okay, so you can see here that the work of a cycle it's equal to the area enclosed in the cycle. It's equal to the area enclosed in the cycle if the cycle is directed clockwise مثل ما نحن عنا الحالة اللي نحن إياها. I will explain why. Okay, ليش الورك للسايكل بيساوي الاريا اللي بقلب التريانجل؟ الورك للسايكل فعليا let me explain it here. الورك للسايكل فعليا هو الورك للAB زائد الورك للBC زائد الورك للCA. Okay, and I'm explaining it for this cycle, but it's true for any cycle. أول شيء البي سي هون it has no work لأنه ما في area تحت البي سي. الwork لل AB it's equal to the area under AB. وين الarea under AB? Let's take a look. هيدي الarea under AB لعند ال V axis. Okay, this is the area under AB. Okay, الwork CA ما تنسوا ال AB أنا جاية من الشمال على اليمين، يعني I'm in the positive sense، يعني جاية من ال V الصغيرة عند ال V الكبيرة. I'm expanding so it's equal to the area. الwork CA I'm compressing، يعني أنا عندي من ال V الكبيرة لل V الصغير، يعني أنا جاي بالعكس. Okay, so if I'm doing a compression دايما الwork لل CA ما بيساوي الاريا، بيساوي minus الاريا. So it's minus الاريا under CA. Okay, so ال AB هي الاريا under AB، بينما ال CA الwork لل CA هو ناقص الاريا under CA. So let's erase. إذا أنا كان عندي هيدي الاريا under AB ونقصت منها الاريا I will mark it in white، نقصت منها الاريا under CA، شو بيبقى معي؟ بيبقى معي الاريا enclosed inside the cycle. So كل مرة أنا بدي أجيب ال workless cycle I can say that the work inside the cycle is equal to the area trapped inside this cycle. So for sure you can see that the area for AB is greater than the area of CA simply because ثابت لأنه أنا عندي السايكل it's rotating clockwise. لو كانت السايكل rotating anti clockwise، لو عم نبرم بالعكس نحن كنت أنا مضطرة أحط minus area AB و plus area CA، كنت طلعت معي ال workless cycle negative. كل مرة بتكون السايكل rotating clockwise بيكون ال work تاعولها positive، بيكون ال work تاعولها positive بيساوي الاريا. كل مرة بتكون السايكل rotating anti-clockwise بتكون الwork تاعول السايكل negative which work done by the gas is negative and the gas is يعني في work is done on the gas. Okay, I will erase all of this because I have explained it. I will erase this and you know now if you have a cycle and the cycle is rotating clockwise, so the work of the cycle is equal to the area trapped inside this cycle. Okay? So it's easy to find the area here. You can see that the area, this is a triangle and we can find the area easily. So Q plus cycle, it's equal to the area, it's equal to base times height over 2. So let's see. Okay, so we've got here from 8 to 2, we've got 6. Don't forget the unit, it's kilopascal. I have to multiply by 10 to the power 3. Base it's from 6 to 10, so I've got 4 times 4, okay, divided by 2. So this is the area of the triangle, which is equal to 12 times 10 to the power 3 joule. And this is the work of the cycle. So what does that mean? That means that our cycle is absorbing heat and the fluid is doing work. يعني الفلويد تاعولي أنا عم يمتص heat وهيدا الهيت عم يحوله work. That's mean هيدا اسمها engine. This is called an engine and I will explain it in the second chapter. This is called an engine cycle because it's producing work. يعني الwork تاعولي اللي عم يعمله الغاز is a positive work. يعني أنا الغاز اللي عندي عم يمتص Q عم ياخد heat وعم يحول هالهيت لwork، عم يعمل work. So in part B, what does he say? He says that what if the cycle is reversed, that is the process follows the path ACBA. So the arrows are reversed, so instead of rotating clockwise I will be rotating anti-clockwise. What is the net energy input per cycle by heat? So we have to find Q for the cycle in case the arrows were reversed. So in this case everything will remain the same, but instead of workless cycle equals area enclosed in the cycle, so it will be workless cycle will be equal to minus the area. So the Q-less cycle will be equal to the work of the cycle as usual, but the work of a cycle is equal to minus area enclosed by the cycle. Okay, so minus the area, so I will get it's equal to minus 12 times 10 to the power 3 joule, and this is the Q of a cycle. This cycle, which is rotating anti-clockwise, okay, this one it's called a refrigerator cycle or a refrigerator, simply because it's a work is done on the gas. يعني الwork للغاز is negative، في شيء عم يعمل work على الغاز، okay, and it's which allows him to lose heat، يعني عم يخليه يخسر heat. Okay, هيدا بيشبه refrigerator اللي شغل refrigerator which we already have it in our homes, okay, in our kitchens. Problem 31, page 636. Consider the cyclic process depicted in figure 20.30, which is the figure of the previous problem. If Q is negative for process BC and delta E internal is negative for the process CA, so he's giving me that Q BC is negative, and delta E internal, he means by delta E internal, it's the internal energy during the process CA. So CA, he's saying that it is negative. If Q is negative for the process BC and delta E internal, the internal energy for the process CA, what are the signs of Q, W and delta E internal that are associated with each process? So for each process, I have three processes, AB, BC and CA. I have three processes. I have to find the sign of the work Q and delta U. Okay, let's start first with the two that are very clear, which are this one. This one is an isochoric cooling. Why it's cooling? Remember that I've explained this in the lecture. When we are going from high pressure to a low pressure, in this case the temperature will decrease. So pressure will decrease, here temperature will decrease at a constant V. Okay, so it's called an isochoric cooling. Down here, the process CA is an isobaric. This is an isobaric compression. Why it's called a compression? Because as you can see, the volume is decreasing. So in this process, the pressure will be constant. Okay, and we'll get volume will be decreasing, and so the temperature will be decreasing. So it can also be called isobaric cooling. So it's the same as cooling. Okay, this is the given. For the process AB, it's nothing from the four processes that we have already learned, which are the isochoric, isobaric, adiabatic, and isothermal. So AB is not isothermal, nor adiabatic, nor isochoric, nor isobaric. So it's just a straight line, it's an oblique straight line, so I can't calculate or I can't guess its Q and its delta U. We will do them during our process. Let's start first with the isochoric cooling. So I will say that BC is an isochoric cooling. Because it's an isochoric, so the work of BC, remember the work is the area under the curve, so you can see that the work is integral PdV, هون V is constant, so I will get work of an isochoric process is always zero. All the time it's zero. كمان ما في area تحت الline, so the area under BC is zero. You can guess it this way. For delta U, all the time delta U BC, okay, it's equal to NCV delta T all the time, okay, for all kinds of processes. So in this case we have cooling, we have decrease in temperature. So when we have a decrease in temperature, delta T is negative, so we will get delta U, which is negative. So it's negative. And now we can guess QBC. QBC it's the same, so QBC it's equal to, similarly to NCV delta T, it's also negative because we are in the case of an isochoric cooling. So you can see that if we apply the first law of thermodynamics, we will get delta U equals Q minus W, and W will be 0, so we will get delta U, it's equal to Q, I'm talking for sure about BC, so this is for BC, this is for BC, which are both of them negative because they have the same formula. Okay, so it's NCV delta T. We have finished from the first part of science for the first process. Let's now move to the second process, which is CA. So CA is an isobaric cooling or compression. Okay, because we are going from large values of V to small values of V. In this case, we can first start with the work. Work is the easiest one. So CA, we are going from large to small values of V. We are compressing. Each time we are compressing, the work is negative. بيساوي ناقص الاريا under the curve. Okay, it's negative. So WCA, it's equal to, or it's negative. I write it directly. No need to calculate them. So it's negative. It's similarly, it's equal to P delta V, and here delta V will be negative, so it's negative anyway. So it's negative. Now let's go to Q. Or let's go to delta U. Both of them can be solved at the same time. So delta U, it's all the time NCV delta T هذه ما بتتغير. Temperature is decreasing, so in this case we have isobaric cooling, so for sure this one will be negative. So delta UCA is negative. Now let's go to Q. Q at an isobaric compression is equal to NCP delta T, and here because the pressure CA for sure, because the temperature is decreasing, the pressure is constant, volume is decreasing, so temperature is decreasing, so we will get NCP delta T, we will get it negative. Okay, so this is for CA. Now let's go back to the third process, which is CA. So AB, sorry, AB, it has no name, it's just an expansion. How do I know it's an expansion? I'm going from small values of V to large values of V. Expansion. So in this expansion, the work AB, it's equal to integral P dV, so V is increasing, so the integral must be positive, so this is positive. Okay, it's equal to the area under the curve, so which is positive. Now for QAB and delta UAB, I have nothing in the shape of a formula, because it's not a known process, so I will use the method of a cycle. I will try to use the cycle because it's easier. Let's start with delta U. So delta U of a cycle, it's equal to delta U of AB plus delta U BC plus delta U CA. Okay, this must be all equal to 0 because we have already explained that U is a state function and it's equal to 0 for a cycle. Now we have already shown that delta U for BC is negative. This one is negative. And for delta UCA, it's already shown to be negative. So for sure, delta AB must be positive. I will allow you to see how. So implies delta U AB, it's equal to minus delta U BC plus delta U CA, because delta U BC and delta U CA are both of them negative. So I will get this positive. Now there remains the QAB. I have to find it. So let's use the first law of thermodynamics. I will get delta UAB equals Q minus WAB. So we've got QAB equals delta UAB plus WAB. Now we have delta U positive, we have work positive, so for sure QAB must be positive. So applies QAB is positive. I will move to problem 32 of the same page, 634. A sample of an ideal gas goes through the process shown in figure 20.32. From A to B, the process is adiabatic. Let me write on the figure, so this one here, it is an adiabatic process. Adiabatic. For sure, this is an adiabatic compression because the volume is decreasing. From B to C, it is an isobaric with 100 kilojoule of energy entering the system by heat. So we have a QBC. This is QBC. It's the energy entering the system by heat. It's equal to 100 kilojoule. When he says entering, he means it's absorbed by the system. So I have to write Q as a positive value. ما بكتبها minus 100. It's a plus 100 kilojoule. هلا without saying it's entering, I can guess alone. ليه؟ لأنه هيدي عبارة عن this one is an isobaric heating. Okay, so this is an isobaric heating. Because I'm heating, so for sure the temperature will be increasing, and in this case Q will be positive. Okay, so I'm absorbing heat. Down in DA, for example, this one is an isobaric cooling. So without he telling me that QDA is negative, it must be negative. Okay, so isobaric, this one is an isobaric cooling. Let me complete reading the given. So from C to D, the process is isothermal. So this one is isothermal. From D to A, it is isobaric with 150 kilojoule of energy leaving the system by heat. So he said that it's leaving the system, which I did expect. Okay, so QDA, it's equal to minus 150 kilojoule. For sure, this must be changed into SI unit. I should never use kilojoule. I have to use the joule. Determine the difference in the internal energy between B and A. So he's asking me to calculate UB minus UA, which is equal to delta UAB. So he's asking me to find this. Now, one might think, how to find, for example, delta UAB. He can use the first law of thermodynamics, which will say that delta UAB is equal to Q minus WAB. هلا QAB, because we are in an adiabatic process, then QAB will be 0. So delta UAB will be equal to minus the work. So we can calculate the work either using NCV delta T, or using, or for sure minus NCV delta T, or by using P2 over P2V2 minus P1V1 over 1 minus gamma, one of these two methods. So in both methods there appears CV and gamma. So أنا لازم يكون معي CV and gamma to be able to calculate delta UAB using the first law of thermodynamics, اللي هي delta UAB equals QAB minus WAB. I will try to calculate delta UAB using the cycle. بما أنه هو أعطاني information about the rest of the cycle, I'll try to do that. هلا in the second part, I will add a part and I will teach you how to calculate gamma, and you can calculate gamma, then calculate delta UAB using the second method. So I will start by calculating delta U for all the three other processes in order to be able to deduce delta UAB. Let's start with BC. So for BC we have an isobaric heating. So BC is an isobaric process. In this case, delta U BC is equal to QBC minus WBC. So he has already given me QBC, so it's 100 kilojoules, so I have to multiply. Let me just leave it and I will substitute W in the case of an isobaric process, it's P delta V. So it's delta V, it means V final VC minus VB, V final minus V initial. So now let's substitute. Delta U BC is equal to 100 times 10 to the power 3 minus, I look at the pressure, it's 3 atmosphere. So it's a 3, atmosphere is not the SI unit, I have to change, I have to multiply by 1.013 times 10 to the power 5, this is an SI unit. Then VC minus VB, VC it's clear to be 0.4 minus VB, it's clear to be 0.09. Don't forget to look at the axis, you have meter cube, it is in SI unit, no need to change. Okay, so calculating this, we will get 5791 joule, and this is delta UBC. Let's move now to CD. Now CD is an isothermal process. Then delta U CD must be equal to 0. No calculation is needed. The temperature is constant and U is a function of temperature. Let's move now to dA. So similarly as we have done for BC, we will say that dA is an isobaric process. Then delta U dA it's equal to QdA minus work dA. Okay, remember that the pressure is constant. It's equal to QdA minus P, the pressure is constant, I can read it from the graph. V final dA, I finished at A, I've started with D, final minus initial. QdA was already given, it was minus 150 times 10 to the power 3, don't forget the unit. Minus, let's look at the pressure. The pressure from the graph, it's equal to 1 atmosphere, so I have to write 1 times 1.013 times 10 to the power 5. And let's look at VA and VD. You can see that VA is 0.2, VD is 1.2. So it's 0.2 minus 1.2. No need to change the unit. Calculating all of this will give me minus 48700 joule. Okay, now I have delta U for the three processes, and there remains the adiabatic process, so I can guess it using the internal energy of a cycle. So delta U of a cycle, it's equal to 0, implies delta U AB plus delta U BC plus delta U CD plus delta U dA must be equal to 0. I can substitute all of them. Remember, I'm finding delta AB, so delta UAB is equal to minus delta UBC plus delta UCD plus delta UDA. I have all of them as numbers. You can insert them and you will get 42909 joule, and this is delta UAB. Okay, using the cycle method. Now I will add a part. This part says calculate gamma, which is the atomicity constant of this gas. Let's calculate gamma. So there are many methods to calculate gamma, but here I have nothing important other than the graph and the cues that he gave me. So he gave me the graph, which relates 2 points. You can see that A and B are 2 points of an adiabatic process. We can find their coordinates. Pressure لل A, volume لل A, pressure لل B, والvolume لل B, they are constant. They are obvious. So I can use them in order to find gamma. This is one of the important methods. He also gave me QBC and QDA. Remember that QBC, it contains CP, and CP also contains gamma, because CP is equal to R gamma over gamma R over gamma minus 1. So in this case I have to find the temperature, so it will take a little bit longer, but I can find it using I can find gamma using QBC. ما تنسوا هي QBC هي عبارة عن NCP دلتا T، بس بتصير تجيب temperature على C temperature على B. I can find them. دايما لما يكون معي بكل نقطة معي P ومعي V فيني لاقي temperature، ما PV equals an RT، يعني فيني لاقي أنا temperature للB، temperature للC، temperature للD، temperature للA، فيني لاقيهم. Okay. So I have to find the temperature. بعدين بحسب CP. من بعد ما احسب CP بربطها بالجاما. I've explained how to do that in the lecture. هلا أنا هون مش رح أعمل هيك، رح استعمل طريقة الأسهل إنه I will say that A and B are 2 points of an adiabatic process. So for sure PV gamma is equal to PV gamma. PV gamma for A it's equal to PV gamma for B. Let me do that. So I will say that PA VA to the power gamma is equal to PB VB to the power gamma. Why? Because A and B are 2 points from an adiabatic process. So I will do that. Implies PA over PB is equals VB over VA to the power gamma. هلا لما يصير عندي pressure no need to change unit, okay, because they have the same unit. So all I have to do is just copy, and then PA it's 1, PB it's 3, so it's 1 over 3 equals VB. Okay, so VB is equal to 0.09 and VA it's 0.2. 0.09 over 0.2 gamma. Now how to find gamma? You just have to do a ln function. So ln 1 over 3 it's equal to ln 0.09 over 0.2 to the power gamma. So ln to the power gamma, so this will give me gamma ln this function 0.09 over 0.2. Okay, so we do it this way. Now I can find gamma. Implies gamma it's equal to ln 1 over 3 divided by ln 0.09 over 0.2. Remember that gamma must be greater than 1. Okay, I will do calculate it. Which is equal approximately to 1.38. So this is gamma. Okay, now if he asks me to find CV and CP, I can easily find them using the formulas that I have already gave you. So let me go back or go down. So this is an extra part that I have added. So if I'm going to calculate CV, it's easy. It's R over gamma minus 1, so R must be given. It's 8.314, and gamma it's already calculated. And if I'm going to calculate CP, it will be gamma R over gamma minus 1. So this is the way we calculate CV and CP. Now I will move to problem 38, page 635. This problem says an ideal gas initially at Pi, Vi, Ti is taken through a cycle as in figure 20.38. Find the network done by the gas per cycle. So network done by the gas, I have already explained. If the arrows are circulating clockwise, so the work done by a cycle, it's equal to the area trapped in this cycle. So here it's easy. We have a square, so or we have a rectangular shape. All we have to do is find its area, so side by side. So we can say that in part A, the area or the work of a cycle, it's equal to the area enclosed in cycle. It's equal to, here you can see that here we have 2 Pi and down we have 3 minus 1, it's 2 Vi, so I will get 2 Pi multiplied by 2 Vi, which will give me 4 Pi Vi. Remember that Pi and Vi are the initial pressure and volume. So this is the work done by cycle. You can also calculate the work done by cycle as work AB plus BC plus CD plus DA. أصلا AB والCD they are isochoric, they have no work. BC it's P delta V, يعني هي 3P delta V. You can do it this way. I will do it for you. كما تشوفوا إنه they will give me the same answer. So or work of a cycle, because here all the lines can be easily calculated, so I can do it like this. It's work AB plus work BC plus work CD plus work DA. Now we have AB 0 because it's isochoric. We have CD 0 because it's isochoric. What remains DC and DA, which are isomeric. So their formula for work is easy, which is P, okay, P delta V, so P VC minus VB. Okay, so what pressure of C or B, because they have the same pressure, I will call it pressure C or pressure P. You can call anyone you like, so let me call it pressure P. Plus work DA, you can pressure of A or pressure of D, both of them are the same, so pressure of A or of D, so let me call it of A. So final minus initial VA minus VD, it's P delta V. بتنقوا البريشر حيلا واحدة منهم because all of them they have a constant pressure anyway. So delta V, it's final minus initial. Okay, البريشر لأول كيس اللي هي البي سي عندي 3 بي اي، الفي سي هي 3 في اي minus في اي plus البريشر للA, you can see that it's PI. VA minus VD, we will get VI minus 3 VI, which is equal to 3 PI multiplied by 2 VI plus PI multiplied by minus 2 VI. Look, the work done by DA is negative. Okay, so فعليا نحنا أول term هو عبارة عن الاريا under the curve اللي هي هيدي كل الاريا ناقص الاريا under the curve DA. so بنرجع بنمحي هون وبيطلع عندي الاريا under the square. Okay, so we will get, I will erase this, we will get 6 PI VI minus 2 PI VI, which will give me 4 PI VI. Okay, let's move to the second part. The second part says, what is the net energy added by heat to the system per cycle? We have to find Q for the cycle. So this is part B. I will use delta U of a cycle equals Q of a cycle minus the work of a cycle. Why? Because I have already calculated work of a cycle, so I will think with this way because delta U will be equal to 0, and I will get Q last cycle, it's equal to work done by a cycle. So the heat absorbed by the system is equal to 4 pi Vi. Now let's do the third part, part C. Part C says obtain a numerical value for the net work done per cycle for 1 mole of gas initially at 0 degrees. So we've got N equals 1 and temperature equals 0 degree Celsius. We have to change it to Kelvin. So N it's equal to 1 and temperature it's equal to 0 degree Celsius, which is 273 degree Kelvin. We have to add 273. Before completing this part, I guess I forgot to write the work done on the gas. So I have calculated this work is the work done by the gas. We usually calculate the work done by the gas, and this is the work we ask for in the exams. Okay, بس هون بالسؤال هو سألني الwork done on the gas. When I wrote the second method, I forgot. So the work done on the gas, which is the external work, it's equal to minus the work done by the gas, which is simply minus 4 pi Vi. Okay, so this is the work done on the gas. Now in part C, he's asking me to calculate this work, the work done on the gas. Never mind, in exams we only ask about the work done by the gas. So we don't ask about W external, we only ask about W done by the gas. So W external, which is the work done on the gas during this process, it's equal to minus pi Vi. Okay, it was, I guess, minus 4 pi Vi. He gave me the temperature, so I will replace pi Vi with minus R and RT initial, and I will substitute minus 4, 1, R is equal to 8.314. This one is 1. Okay, and the temperature is 273, and I will get minus 97.8 joule. And this is the answer. Now we will do problem 40, page 635. In the figure 20.40, the change in internal energy of a gas that's taken from A to C is 800 joule. So we have delta UAC, it's equal to 800 joule. The work done on the gas, he's giving me the work done on the gas. In this chapter, he always gives me the work done on the gas and not by the gas. So the work external on the gas during the path ABC, so for the path ABC, it's equal to minus 500 joule. So I will change it to the normal work done by the gas ABC, it's equal to 500 joule. How much energy must be added to the system by heat as it goes from A through B to C? So he's asking me to find the QABC. So I will simply use the delta U, the first law of thermodynamics. Delta U along the path ABC, it's equal to Q along the path ABC, okay, minus the work along the path ABC. بالنسبة للدلتا U along the path ABC أنا بهمني بس initial و final points، ما هي final minus initial, so it's the same as delta UAB. It's 800. This one is 800. The Q, I'm searching for it, so this is part A. I'm searching for Q, ABC. The work, it's AB. This is, I forgot here the A, so ABC, it's 500. This will give me QABC equals 800 plus 500, which is equal to 1300 joule. Part B says if the pressure at A is 5 times that of point C, what is the work done on the system? Work done, he always asks for the work done on the system. We will do our normal work. احنا هنشتغل على work done by the system بعدين نستنتج work done on the system. Is going from C to D. Okay, so PA is equal to 5 PC. The problem in this part here that we have no coordinates for A and C and other points. We have nothing. We have nothing related to work other than work for ABC. It's equal to 500 joule. So we will use this work ABC. It's equal to 500 joule. So you all know that the work of ABC is divided into processes, which are AB plus the work done during BC, which is equal to 500. So the work done during BC is 0 because simply BC is an isochoric process and its work will be 0. So we can deduce that the work done by the gas during the process AB alone is 500 joule. So it's 500 joule. Now he's asking me to find the work done during CD. He's not asking me to find the work done during AB, but he's giving me a relation between A and C. Let's put in front of us the formulas for the works of AB and the work of CD. So the work of AB, it's equal to the pressure of A or pressure of B, because both of them have the same pressure, VB minus VA. Okay, and the work of CD, it's equal to pressure of C, for example, any one of the pressures, C or D, but he gave me a relation between A and C, so I have written C, VD minus VC. You can clearly see that there's a relation between VA and VD, so VA, it's equal to VD, and VB, it's equal to VC. So I will replace them down, so I will get PC into VA minus VB. Okay, so let's divide the two equations together. I will divide work of AB divided by the work of CD. It's equal to PA VB minus VA over PC VA minus VB. So these two brackets, they are multiplied by a minus sign, so there remains minus PA over PC, and I already have a relation between PA and PC. I will get minus 5 PC over PC. It's equal to minus 5. So فعليا الwork لل AB it's equal to minus 5 الwork less CD. Remember, we are searching for the work of CD, so implies the work CD it's equal to minus 1 over 5 الwork lel AB. Work lel AB was found to be 500, so minus 1 over 5 times 500, which is equal to minus 100 joule. This is the work done by the gas. If he's asking for the work done on the gas, so external, it's equal to 100 joule. And this is the answer. Now part C says, what is the energy exchanged with the surrounding by heat as the cycle goes from C to A along the green path? So as you can see, we're going along the green path. Okay, we're going to go along the green path and we are going to find the energy exchange with the surrounding by heat. So we are going to find the Q, C, D, A along this path. So he's asking to find Q, C, D, A. So part C, he's asking to find Q, C, D, A. Okay, so I will use the first law of thermodynamics, which says delta U C D A, it's equal to Q along the path CDA minus the work along the path CDA. So to find this, delta U along CDA هي simply U final minus initial اللي هي إذا بدي أنا it's equal to delta U بس CA. أنا ما بيهمني إلا بس initial and final points, which is equal to minus delta U AC. And I have AC, so it's the inverse of it. أنا بس بيهمني initial and final, which is equal to QCA QCDA minus, so the work is divided in two parts. It's WCD plus WDA. So you can see that DA is an isochoric process. The work here is 0, so this will be removed. The CD أنا هلا بعدني حاسبيتها, it's minus 100. So we will get this one. I will substitute minus 800. ممكن أعطيني الدلتا UAC بأول السؤال 800, so minus delta UAC, it's minus 800 equals QCDA minus the work لل CD I've already calculated it, it's minus 100 and it's plus 100, so I will get QCDA equals 900 joule, or minus 900 joule, and this is the answer. Okay, now part D says if the change in internal energy in going from point D to A is 500 joules, so he's giving me delta U dA. This is part D. He's giving me delta U dA is equal to 500 joule. How much energy must be added to the system by heat? So we have to find Q as it goes from point C to point D. So he's asking me to find QCD. Okay, let's try to find. We have already found QCAD, which is for sure QCD زائد QDA. رح احاول الاقي QDA اللي هو معطيني دلتا UDA ومنها بستنتج ال QCD. So delta UDA it's equal to QDA minus WDA. اوكي الDA هو كان عندي isochoric, so الwork لعنده 0, هيدي طارت 0, so we will get implies QDA equals delta UDA equals 500 جول. صار معي ال QDA. هلا أنا حسبت ال QDA along QCDA along the path CDA. So now QCDA هي عبارة عن ال Q along the path CD زائد ال Q along the path DA. اوكي هيدي حسبتها minus 900 equals QCD plus 500, so I will get QCD equals minus 900 minus 500, which will give me minus 1400 joule for sure. So this is QCD.